Homework 14, Rational Functions, Video 3, Horizontal Asymptotes. As in the previous video, which discussed vertical asymptotes and how to locate them, we will be using an arrow to represent the word approaches. So let's start with fixing this definition. You can probably tell I just erased and changed several things on the board from the previous video, but I forgot to erase and change the word horizontal to vertical. So, a horizontal asymptote is a horizontal line which would have an equation y equals a number, so we'll say y equals c, such that as x approaches infinity or x approaches negative infinity, we have y approaches c. Let me put it in a different context. About 3 videos ago, we discussed end behavior. Both ends rise, both ends fall, left falls, right rises, left rises, right falls. Well, a horizontal asymptote is basically also dictating end behavior. But instead of the left end rising or falling, it might settle down to a number. And the same thing with the right end. Instead of rising or falling, it might settle down to some number without ever actually being that number. So that's what a horizontal asymptote is. It's a horizontal line such that as x approaches infinity, so it goes to the right, or x approaches negative infinity, goes to the left, we have y approaching that value. And just like vertical asymptotes, there's a straightforward way to locate horizontal asymptotes. But instead of solving anything, you just compare. You compare the degree of the numerator, which I'm going to call n, with the degree of the denominator, which I'm going to call d. Remember that degree is just the highest power. So this is saying the same thing as saying the highest power in the numerator and the highest power in the denominator. One of 3 things must happen. Case number 1, if n is greater than d, meaning that there's a bigger power on top than on the bottom, then there is no horizontal asymptote. Your graph doesn't level off. The ends either rise or fall. However, case 2, if n is less than d, meaning that the smaller power is on the top, bigger power on the bottom, then the horizontal asymptote is always y equals 0, which is a fancy name for the x-axis. So if there's a bigger power on the bottom than the top, then your graph will flatten out onto the x-axis. The third scenario is that the degrees match. The same highest power on top is the same as the highest power on the bottom. If that happens, you actually have to make a number. The number that you make is the ratio of leading coefficients, meaning that you just take the numbers in front of the biggest powers and make a fraction out of them. And y equals that fraction will be your horizontal asymptote. So let's take a look at 3 examples, which is suitable because we have 3 scenarios. Example 1, I believe, is the same first function we had for vertical asymptotes. F of x equals x plus 3 over x squared minus 4. And the question is, what are the horizontal asymptotes? Well, let's start by explicitly listing the degrees. Remember, degree is the highest power. On the top, the highest power is 1, and on the bottom, the highest power is 2. So we have n is less than d. So this means that the horizontal asymptote is y equals 0. That's actually kind of easy to explain why it happens. The whole purpose of a horizontal asymptote is to dictate what happens on the ends. In other words, what happens when the x's get really, really, really big. If the x's, imagine these numbers are growing, the x's are growing, larger and larger and larger. Which side of the fraction would grow faster? The answer, the bottom one. Y has the bigger power. So as the x's get bigger, both sides of this fraction are growing, but the bottom of the fraction is growing a lot faster than the top. So relatively speaking, it's outgrowing the top, and so the fraction as a whole is shrinking all the way down to 0, or getting closer to 0. If that made sense, great. If not, just remember, bigger power on the bottom, horizontal asymptote is y equals 0. Second example, f of x equals 2x squared minus 4 over x minus 4. Not the same as the second example from the last time. I inserted a square on the top. But let's compare degrees. The degree on the numerator, the highest power in the numerator is 2, but the highest power in the denominator is just 1. So in this case, we have the numerator with the greater degree than the denominator, and when that happens, there is no horizontal asymptote. What that means is as the x's get larger, the right end either rises or falls, as does the left end. I can tell you right now that for this one, the right end would rise and the left end would fall. But again, if the larger power is in the numerator and the smaller power is in the denominator, there is no horizontal asymptote. One more example, we'll look at f of x equals 2x squared over 3x squared plus 1. Again, we're just comparing degrees. In the numerator, the degree is 2. In the denominator, the degree is 2. The degrees are equal. And when that happens, your horizontal asymptote is y equals the ratio of leading coefficients, which is a fancy way of saying put these numbers on top of each other. So really, there's not much to calculate here. At a bare minimum, you set up a fraction that either divides or reduces, but these two are observational. So locating a horizontal asymptote is pretty easy if you know all you have to do is compare degrees and what to say in each of these three cases. In the next videos, we're going to put it all together. We're going to look at some functions. I think we'll look at this one first since we've already located its asymptotes. I've got a laundry list of functions on the sideboard. And we're going to go through what the homework refers to as the 7-step process for graphing these guys. Don't worry, none of the individual steps are bad. It's pretty easy to put together.